Okay, so today we are going to be talking about input-output tables, which is kind of building on this idea from last week where we took coordinates and we put them on a graph to represent them visually. And so building on this idea, we're going to take some ideas that we learned during the algebra unit about writing expressions to represent relationships. And so we're going to go quickly through some examples to kind of review converting words into numbers. So the first one, it says, write an expression that represents 4 less than 3 times a number. Well, we know that less means subtraction and times means multiplication. And so if you look at this part first, this 3 times a number, and we know that we represent numbers using letters in algebra, you have 3 times x. And then we have 4 less than this number. So we know that less than means subtract, and then we've got 4. We're going to go 3 times x minus 4 represents 4 less than 3 times a number. The next one is a number divided by 6 plus 3. This one's a little bit easier just because it's kind of, you read it left to right, and it can be represented the same way. So you have a number, so we're going to use x again to represent the number, and we divide it by 6. And you can either use the dot and 2 dots in a line, or you can actually go x and then just put a line divided by 6. And then plus, we know is plus, or addition, 3. So again, that's representing this expression, a number divided by 6 plus 3 is equal to this. Then looking at this one, Matilda is filling the bathtub at 40 liters per minute, and that is crazy fast. Like, that would be, your whole bathtub would be filled in a minute, which is crazy. But this is the expression that we're looking at. So we're going to write an expression to show that the volume of water after t minutes, which t is just a number of minutes. We don't know what. And so the way this works is you've got 40 liters, and then per minute, you'd go per minute. And to find out how many after a certain time is you actually would multiply that by t minutes. But if we wanted to simplify that and get rid of all the units that we have talked about in previous units, we would just take the number and the number or the variable that we're looking for. So we just go 40 times t. So we're going to represent it like 40 and then dot t, or if we remember from algebra, you can actually just put 40 and then the letter t, and it will, it means multiplication. The next one is Janine has 5 less trophies than Caroline. Write an expression to show how many trophies Janine has. So we're looking for how many Janine has, and it says there that she has 5 less trophies than Caroline. So what we're going to do is Caroline is going to be the number in the variable in the expression, and Janine is going to be what we're looking for. So this is a little bit more complicated, and since we're just doing expression, we don't have to do an equation, but you could have Janine be y and Caroline be x. And so we would have Janine is equal to x minus 5 because it's 5 less trophies. But since we're writing an expression, not an equation, you can actually just make it x minus 5. So that is representing numbers, or representing letters using numbers. So we're now going to go into that and look at how to substitute different numbers for the variable to create input-output tables. So that's what I'm going to write right here. So we're going to substitute different numbers in for the variable or the letter. So in this case, it's going to be N or X or A, any letter you want to create what we call an input output table. And the reason we call it an input output table is because you input a number and you output another number because you're putting it through an expression. So looking at this first one, what I like to do is whenever I'm replacing the letter, I always put it in brackets. And that way, if it's next to a number, it reminds me to multiply. So in this case, we're going to go 3 bracket, and we're going to input this 1 minus 2, and we're going to find out what it equals. So 3 times 1 is 3, minus 2 is 1. So that would be put right here. And you keep doing that with the same expression, and then you solve it. So again, 3 times 2 is 6, minus 2 is 4. And just keep going. And you can pick any numbers that you want. In this case, they've been given to you. In the next example, you're going to have to supply your own. So 3 times 4 is 12, minus 2 is 10. And let's just keep going. So we have, here's a full input-output table. So I'm going to scroll down to the next example. And this one's a little easier because it doesn't have 2 steps. It's just 1 step. So we're going to go, again, I like to put the brackets just to remind me. Okay, so then we have 1, 5, 2, 6, 3, 7, and 4, 8. So sometimes I'll give you the numbers and sometimes I won't. So going back again, and again, it completely is up to you what ones you want to do. I usually honestly like to start with 0, 1, 2, 3, 4. And the reason I like to do that is the smaller the number you choose, the more simple the answers are probably going to be, just because you don't need to multiply bigger numbers. So again, we're going to put this X number in for this expression. So actually, this should be replaced with an A. So you're going to go in and you're going to write 1 plus 9, and then you're going to put the brackets 0. And we know 9 times 0 is 0, plus 1 is going to be 1. And then we're going to go and do the rest of those. Oops, wrong number. Second. And again, we have, so it's going to be 0 and 1, and then 1 and 10, 2 and 19, 3 and 28, and 4 and 37. And so this one, you see, kind of gets much larger, much quicker, and that's probably because of the fact that we have to multiply it by 9. And I'm just going to speed through this last one, but again, pick the same numbers. It's nice and simple. We're going to go through. I'm just going to put them right here. So 2 times 0 plus 3 equals 3. Oh, wrong number again, sorry. I'm gonna go back. I'm gonna put 4, and that's the final one, plus 3 equals, so 2 times 4 is 8, plus 3 is 11. So we're gonna plug all those numbers in. And that's how you fill an input-output table. So that's it for this week. We're then going to learn how to graph them next week.